I want to go ahead and review the week 5 material that we've looked at this week, talk about what you're responsible for and the different forms that I'm going to be testing you, I guess, on these particular topics. So let's just jump into it. We did regression analysis. Specifically this week, we spent a lot of time looking at multiple regression analysis, and there were several different tasks or topics that we worked with. Model building. In general, I'm going to be giving you variables and ask you to be able to build models, complete second order models. I'm going to ask you to go through the game plan technique, the model building technique, and work down from our complete second order model down to what I would call, or what you should call, your best model. You're getting a lot of practice, I would think, in your project this week, working with your project data. But I'm going to expand that a little bit on your final exam that's coming up. I'll give you some problems that look like your project, but I'll expand that and give you other problems that are more complicated than your project, that have more than just a quantitative X1 and a qualitative X2 that has 2 levels. So really dig in and try to understand the model building portion of the regression analysis. Final model interpretations is the second topic I'll mention. Things like the standard deviation and R squared, confidence intervals and prediction intervals. Confidence intervals, we talk about using E of Y, the average of all y's that have certain settings of the x's. Prediction interval is the name that we give to a single value of y. They're both confidence intervals, but you should be able to know where the material is located on the printout and then be able to interpret those confidence interval endpoints. Again, you're going to get to do a lot of that on your project. Beta interpretations are less important than they may have seemed when I first introduced a simple linear regression, but we can still gain some knowledge. And so being able to interpret the betas, if I show you a model and say, hey, well, how would you interpret the betas here? It gets a little tricky when interaction is present, but you might be able to do some beta interpretations for me. The next topic is residual analysis. Again, you're getting your best practice, I would think, on your project, where you're going to do the residual analysis plots, be able to generate all the plots, be able to know what plot to generate, be able to go through the process of creating that plot, and then know how to interpret it. Tell me what the results indicate. Is there a problem? Is there not a problem? And then if there is a problem, you should know how to make corrections. On your projects, I'm asking you to do a lot of the interpreting. I'm not asking you to make any corrections on your projects. That may change on the final exam. I may ask you some more specific questions on the final exam about how you would fix any problems you might have. So residual analysis is a big topic. And I'll mention this about residual analysis. A lot of times I find students spend a lot of time worrying about model building, and they don't put enough time into residual analysis. So just something to kind of keep in the back of your mind. Make sure you put enough effort into that residual analysis topic. That's where I stopped your projects. I typically don't ask anything on the projects dealing with the last topic I covered, and that was the miscellaneous regression items: multiclinearity, extrapolation, and stepwise regression. 3 topics that fell outside. I wanted you to get working on the project, and I didn't want to wait until I covered these topics. But multiclinearity is where our independent variables are related, and relationship sounds like a good thing, but relationships within the independent variables is not a good thing. And so make sure you know a little bit about multiclinearity. Extrapolation is pretty easy. That's where we're just using our regression model in appropriate ways for values of x that we shouldn't. That's a pretty easy one to deal with. Stepwise regression isn't necessarily an easy topic, but probably the biggest problem with stepwise regression is that people use it incorrectly. We should use it to help us identify variables that'll help predict y. Some people use it as a complete multiple regression analysis, and that's faulty. So I want you to know what it's doing, but more importantly, how we would use it. So those are 3 extra topics that I went through this week. And then the last one I'm going to list here is graphing a regression equation, and it's definitely tied into this one up here. So you kind of think these guys as a team. I listed them first and last. But when we're doing our model building, we start with a big complete second order model, a mess. And then we build down. We test the quadratics, we test the interaction, we test this qualitative variable, maybe we test that qualitative variable if there's more than one. And we work our way down to what we think is our best model. Sometimes people refer to that as the most parsimonious model. But we work and we build down to our best model. We say down because the model can only get smaller, right? If we're not using something, we get rid of it. And so it gets smaller. And so we build down to our best model. What I would like you to be able to do is to draw a picture of that best model. Show me what it looks like. And so there's three main things I want you to be able to do with a graph. If I say, here's the model you're working with, you should be able to tell me whether the relationships involve lines or curves. Is the relationship between y and one of the quantitative variables linear or curvilinear? It's usually a pretty straightforward question, pretty straightforward answer too. The toughest question, which I'll list second, is how many equations are represented there? And typically I want you to look at the qualitative variables, if there are any, in your model, and try to determine how many levels are being represented. Remember, we talked about working with qualitative variables and we worked with dummy variables. A lot of times you need to go back there and review this topic, but try to figure out how many levels are represented in my model. And then if there's more than one, which in a lot of cases there are, you have different locations or different models of vehicles, and they are important, they matter, they stay in the model. If you have some qualitative variables, have some different levels, you're going to have more than one equation on that graph. And then my last question, so first is lines or curves, second is how many equations, and then the third one would be, are those equations parallel or non-parallel? And that's really an interaction question. And so I would expect you to be able to do the model building, and then once a final model is arrived at, I would expect you to be able to explain it to me. And I can do that in a variety of forms. I can actually show you some printouts, or I can just talk about it more generally by saying, here's some variables, here's a model, here's the, spell it out in terms of E of y is equal to beta naught plus, and then spell out this big old model and ask you to work with it. But those are all things we talked about this week. The final model interpretations really just kind of piggyback on some other material we've done in earlier weeks, but they are the same. Model building, residual analysis, these extra topics, lots of stuff going on. So try and get caught up. I got a quiz or an assessment, I guess I call them, that I'm going to be giving you, and a project that's due. And of course, these topics are going to show up again on your final exam. So the sooner you know them, the better you're going to be. If you have any questions, you know how to get hold of me. Good luck.